Hi, my name's Nathan Shepard. I work at Esri as a 3D product engineer. It means I work on software development and try to encourage people to think in a 3D way. I'm here today to answer 10 questions about 3D. This question comes from Islamuddin. How can we export the 3D map at a good resolution? ArcScene and ArcGlobe both have limits to what kind of resolution image you can export from them. It can be a real challenge if you want to print these out into large formats. So ArcGIS Pro, we've taken away those problems. We've just made it possible to export very, very large images. And you do that just by exporting the map and then you set the DPI, or dots per inch. And then it's just a pure mathematical number. So from a 3D view in Pro, we assume a 10-inch by 10-inch export. And if you say, I want 100 DPI, 100 times 10 inches is 1,000 by 1,000. That's a pretty small image. But if you set the DPI to say 5,000, then you'll get a 50,000 by 50,000 pixel image exported right from Pro. And I know this works because I did it just before this video, so everything's good there. You can just use that technique. And also with 1.2, you can export out a series of these images as frames, and then if you snap them all together, then you've got a movie. So you can do a HD movie directly from Pro and just export it straight out. That's coming at 1.2. The next question comes from Adam R. How do you dynamically alter a 3D surface once it's already been published without lengthy computational overhead? Unfortunately, if you're doing a full or replacement of your surface, like you're fully replacing it, maybe you've got some new LiDAR, unfortunately you have to do it the hard way. You have to replace the data and you have to recache it and republish it. There's no way around that. However, if you're just working with a small area, maybe an area of interest, or maybe one little piece has been updated, you can actually publish that one piece as its own service and then mash them up on the fly, sort of like a sneaky way to get multiple surfaces together. And this technique works in Pro, works in ArcGlobe, and also works in the web scene viewer, so you can use this across the platform. Now, your question kind of almost implies maybe it's about editing and sculpting terrain as well. We don't have anything for that yet, but it is on the list and we're hoping to get to that in the next year or two. So if you have some thoughts about what we should do for interactively sculpting the terrain, please send your comments in. We'd love to hear them. The next question comes from Alexandri. Can you offer an alternative to Google Earth 3D modeling of buildings and vegetation? It's a fair question, but no. Now we have business partners who do this. And if you're working in an area of interest, like maybe a particular city or a particular zone, there's business partners of ours that you can contact who can provide you with this data or capture it specifically for you to your specifications. So that's the way I'd recommend to go with that. What we are working on at Esri is making it easier than ever to model your own buildings and your own trees and vegetation. You can just sort of own your own data and be the master of your own project. This question comes from Arfan S. How can one extract rectangular rooftops from satellite image data? We don't have any tools to extract footprints or any kind of content really directly from imagery, from satellite imagery, but if you've got multispectral data, then we do have tools for using classifications and different signatures of the image itself to classify areas of the image and then extract features from that. So that's one way to go. And of course, you can always manually digitize against that aerial image if you have the time or someone has the time to do it for you. The other thing too that I'll talk about a bit later on in one of the other questions is using LiDAR to extract this kind of information. So rather than satellite imagery, using LiDAR for this technique. This question comes from Dan P. True 3D, is it coming? Like the ability to define a vertical surface or vertical lines? When is 3D going to extend beyond visualization? And what about 3D raster analysis? This is a great question. We get the true 3D question a lot, and it means different things for different people. And in fact, the answer is we do it already for certain use cases and not for others. So it kind of depends what you need to do. So for example, vertical lines for pipes and for, say, elevator shafts inside a building, we support those. You can digitize them in, you can run network traces against them. We don't support vertical polygons, you're correct there. We support vertical meshes in multi-patches, so you can model your walls and fences and stuff like that using multi-patches. And if all of those triangles in a multi-patch happen to sort of snap together to make a shape, like a cube or a sphere or some weird shape, then we can answer questions like the volume. What's the volume of that? So when people say 3D on true 3D, they kind of mean a mixture of all of these things, and we have some answers for some and not for others. The other thing that you mentioned was 3D rasters. Another way of saying that would be voxels, a notion of like sort of stacked vertical spaces that connect together in 3D. That one, unfortunately, is a little further away than I would like. We are working on it, or at least talking about working on it. So that's maybe 2 to 3 years away, and hopefully you'll start to see some things for that. This next question comes from Ted C. What's coming in the 3D space for ArcGIS Pro at 1.2 and 1.3? So first of all, animation and video export. So you can create videos and export them and share them out. You'll be able to do that at 1.2. We've got enhanced 3D editing capabilities. This new Z-plane, configurable Z-plane, so you can digitize in free space. That's coming at 1.2. Built-in surface shading. So now you can just make, you can add a hill shade to your ground without needing the actual data. So you can run it against surfaces and services. So whatever the ground is made up of, we can shade it for you automatically with just one checkbox. That's pretty cool. And also publishing 3D content as scenes, like a little fish tank scene. You can publish out web scenes directly from Pro using that at 1.2. 1.3 we're still working on what we're going to do. But some things that we definitely want to try to do is publishing elevation services directly from Pro. So it'll be easy to get your elevation content out as a service. We're doing more 3D content. Bathymetric data will be available as a service that you can consume across the platform. And also some 3D symbols, some people and cars and people on bikes and stuff like that that you can put into your scene to make it look more realistic. We're also doing better handling of interior spaces and floor-aware data. That's a real area that we want to work on across the platform for the 1.3 release and beyond. This question comes from Alan K. Does Esri have a viable, consistent engine for performing merge, intersect, and subtract operations on BREP, or boundary representation, geometries? So we effectively model BREP style geometries as multi-patches in the geodatabase, and then you can use that with analytical tools. Now we've actually embedded a library called CGAl, C-G-A-L, inside ArcGIS, and then our analytical tools run against it. So if your multi-patches, like these BREPs, if they're enclosed, they have the watertight, so all the triangles sort of match together and enclose a space. Not only can we tell you what the volume is of that shape, we can also run these CGAl-based analytics against it. So the intersect, merge, and subtract kind of style operations work just by sort of cutting pieces out from each other. Now, some of the pros of using this library is it's a very robust, well-defined, well-established library that we're using that's being actively worked on and improved. And some of the cons, it's geometry focused. So if you have textures on the sides of this, like your buildings maybe have textures on it, when you use this library, it will actually lose those textures and you just be left with a geometry. So it's good for analytics, and it's less, not designed for, let's say, sort of splitting up interactively your textured multi-patches. If you want to learn more about how CGAl works, you can go to segal.org, check it out. This question comes from Jawad. Are you guys planning for a 3D augmented reality feature in ArcGIS in the future using mobile devices? Visualizing 3D GIS in the real world using locations would be awesome. This is fantastic. I mean, the good news is that the Runtime API already has support from this. You can access the sensors on your devices. You can find out where the device is and where it's pointing. You can use that information to sort of put together some sort of smart text or other items that would go on top of the screen, and then just place it there. Now, some of the guys on the mobile team, Runtime team, have done some work with this, and they've shown me, and it's pretty cool. You might have seen some of it, I'm not sure. There's some little videos out there, and we do show it at the UC every now and then, but we don't have anything out of the box for you to play with. If you're really interested in this, I recommend that you sort of send in your information and ask for some stuff, and I'll see what I can get those guys to share with you. I agree, I think this is a really exciting way to go. This question comes from Robin W. Is there a workaround for showing extruded polygons in ArcGIS Portal? As I understand, this is not yet supported. You're correct. We do not support extrusion as a symbology option in Portal yet. We are working on it. The plan is to bring this into 10.4.1, so that's the timeline. For now, there is something you can do. You can convert your extruded polygons, these blocks, these buildings, or whatever they happen to be, these things that sort of stick up from the earth, into real 3D features, into multi-patches, by running a GP tool called Layer 3D to feature class. You run this one tool, it changes the data type, and it burns in that extrusion into a locked model, if you like, so you can't change the extrusion anymore, but then that is something that you can publish to Portal with currently released software. So that's the workaround for now, and we'll make it better in the near future. This question comes from Jerusa C. I hope I said your name right. What would be the best LiDAR to multi-patch procedure? I love this question. Most people think that it's the magic button, turn this bunch of points into a real 3D object. I want a nice, beautiful house from a big pile of points. Can you please do that for me? That's not what I think it is. I think it's more about knowledge extraction. So if you've got LiDAR, a question that's really easy to answer is what's the, all of these points, but if you've got a building footprint, you can sort of think about that going up, and then it's very easy to find all the points around the outside of that building and get the eave height. That's one number. And you can also look at all of these other dots that sort of come up and down like this, and you can get a roof angle. And with those two numbers, you can actually procedurally generate a building model that's close enough to the real world for a lot of use cases. Now, it's not going to be everything, and it doesn't get all the nooks and crannies that these other methods can get, but it's much more viable and much more extensible to use for a lot of GIS practices. So we're chasing that down first, and then as time goes by, we'll get more and more detail about all the elements, the number of windows or the number of floors. All of these things can be extracted from the LiDAR, added as numbers, and then procedurally generated, and you get really good quality content just by extracting knowledge from your LiDAR rather than features from your LiDAR. I hope that helps. Thanks for all your great questions. It's really good to see people interested in 3D and pushing us, taking us forward into this interesting new world of 3D GIS. Of course, if you're interested in learning more, you should follow us on YouTube. We've got lots more videos coming out, and you can always join the conversation on GeoNet. Thank you.